Good morning and welcome to this class. I wish you a very happy new year. Welcome back from the happy holidays. I want to thank God, Jesus Christ, that He has kept you safe this day and tell you that He loves you so much. If you have not accepted Him as your personal Lord and Savior, you should make that consideration now. Do not postpone that decision because Jesus needs you, and you too, you need Jesus Christ. So under fluvial geomorphology, we are simply looking at this domain of geomorphology, which discusses the work of rivers or streams. And we know that streams of all sizes have the basic function or perform some basic functions, i.e. they move water, they move sediment and other matter over the land surface and ultimately empty all these materials into the ocean. So what we are looking at here is a river which refers to a mass of water flowing through a definite channel of a landscape, i.e. from the source to the mouth. The river source is usually where the river originates from. It can be meltwaters of a glacier, it can be a river, it can be a lake, like for example Lake Victoria, which is the source of the Nile. It can be a spring, for example the Thames river in England, which originates from a spring. It can also be formed following a steady rainfall, for example the River Congo in the Democratic Republic of Congo. Whereas the river mouth, on the other hand, can be anywhere a river pours its waters, for example a lake, an ocean, or a sea. Rivers perform three functions, that is erosion, transportation, and deposition. These functions, of course, under erosion we talk about how the river either undercuts its valley bed or valley sides or its headward, i.e. when it comes to extension of its length. And river erosion occurs in three ways. We have headward erosion, we have vertical erosion, and we have lateral erosion. Headward erosion is the cutting back of the river at its source. It is through this erosion that the river increases its length. For example, if a river is originating from a cliff, it keeps cutting the cliff, or a mountain slope, it keeps cutting it and further increasing its length. Vertical erosion is the erosion by which a river deepens its channel. This is erosion which takes place on the valley floor or the channel floor. Lateral erosion, it takes place on the valley sides or the channel sides, and therefore leads to the widening of the river valley. Rivers erode in three processes, i.e. hydraulic action, which simply refers to the process by which the force of moving water plucks and sweeps away loose materials such as silt, gravel, and pebbles. I'll give you a scenario of when you go to urinate. As you pour your urine to the ground, that the force of that pouring urine is plucking material from the ground, and that's why you are able to leave behind a small depression where you've poured your urine. When you move out with water in a basin after washing and you pour that water on the ground, on the surface, that water plucks material from the surface. The other process through which a river erodes is abrasion or corrosion. This is when the load of the river rubs it against the bed and the sides of the river channel and causes the wearing away of the sides of the bed. And of course, this one definitely depends on the amount of the load, which will determine the nature of its erosive power and as well the rate of erosion. So under corrosion, we are talking about the load of the river rubbing against the bed. For example, if you have a boulder as part of the river's load, this boulder is rubbed against the bed of the river. So under corrosion, that's what happens, that the river rubs the bed, losing its load, and definitely leads to the widening or the deepening of the river valley. Attrition is when the rock fragments in the river are broken into further fragments due to collision against one another. You know very well that when material is being transported from the upper course of the river, it's usually a very large load. But as it approaches the delta, it's very small and fine material. The process which reduces the size of those fragments is the one we refer to as attrition. Then corrosion or solution occurs when a river dissolves certain minerals, leading to dissolution and disappearance of some rocks, for example limestone, rock salt, and chalk. And this usually happens when the material is soft or permeable. All these processes, including river transport and deposition, of course the next process is river transport, and we say that this is the process which involves the carrying away of weathered and eroded loose materials from one place to another. All rivers of all sizes perform this function. They transport material. The materials carried by the river are called the load, and the river transports its load in 4 ways. One is saltation. Saltation is hopping. Material goes on jumping and grow and falling, and it's responsible usually for the formation of potholes on the riverbed. The other one is traction. Traction is dragging. Like if some of you, my friend here, Wairagala, said that he's a farmer. He said he has got goats. So when you are taking the goats for pasture, you know they are very stubborn. Sometimes you just drag them. That is traction. Sometimes even it drops on the ground and you drag it by its stomach to reach where it's. And the funny thing is that when it reaches the pasture, it begins enjoying, and you wonder what was the problem with it. So that is it. This is the dragging or rolling of large boulders. Then suspension this happens to material which can be suspended within the water and transported. For example, sand can be suspended in the water and transported to another place. Lastly we have solution, and the solution, this one usually happens to the dissolvable matter or minerals which can dissolve in water like salt and carried away in solution form to another location. A river usually transports its load until it has insufficient energy to transport it any further. And when this happens, the load is usually deposited. So here we also realize that all these 3 processes that the river performs, including deposition, depend on the competency of a river. When a river deposits its load, then it means its volume and speed have decreased. When the volume of the river decreases, it usually happens when it enters an arid area, especially hot desert, where there is insufficient water to add on to the volume. When it crosses a zone of porous rocks, like limestone, which absorbs some of the water, or during the dry seasons when there is no rain to add on to the river. A river speed decreases when it enters a lake, or see for example the Nile River, when it enters the Choga, its speed tremendously decreases because it's trying to maneuver through the waters of the lake. It also happens when it enters a flat or gently sloping plain. We know very well that river flow, water flow is by force of gravity. So if it enters a place of flat terrain, there it means that the force of gravity is minimal, and therefore the water will tend to move sluggishly. But the sluggish movement of water also impacts on its ability to transport material, and therefore eventually deposition is going to occur. So deposition occurs when the river has insufficient energy to carry its load. We know very well that these 3 processes depend on the competence of the river. The competence of the river is defined by its energy. The energy of the river is defined by the ability to transport, to carry material. And definitely this energy is supplemented by the volume of the water in the river valley, but also the speed of flow. When the speed of flow is high, then it means the river has got the ability to carry materials to the lower elevation, to the mouth. So this takes place at any point in the river's course. When it loses its energy, this material is taken to the river's mouth. So I was saying that deposition usually occurs at any point whenever the river loses its energy. So those three processes are defined by the competence of the river or the river's energy. When you are energetic, like you people, younger people here, you are still very energetic. You have a lot of, you still have a lot of energy. That's why you are able to carry huge load. You can carry, my friends here in the Erigon here, they can carry 100 kilograms of cabbages on their backs. But when you grow up and become like me, you start carrying small load. Then the long profile of the river is the other concept. And when you talk about the long profile of the river, usually is the line following the course of a river from its source to the mouth. And along this long profile of the river is distinguished or divided into three sections. We have the upper course, we have the middle course, we have the lower course. This is the upper course usually is the first stage of the river, sometimes also known as the torrent or the useful stage, characterized by high speed of flow of the river, pronounced vertical erosion. There is also the V-shaped valleys. The slope of the profile is very steep and sometimes utilized for hydroelectric power generation because it's characterized as waterfalls in this section of the river. What about the features which are shaded with this stage of the river? Several features are shaded with it because remember I said that the river performs three functions of erosion, transportation, and deposition. And through these functions, it leads to creation of landforms or features. So within the upper section of the river or the useful stage of the river, certain landforms form as a result of those three processes. Of course, we know very well that the deposition is very minimal in the upper stage of the river, but there is pronounced erosion, and usually this is vertical erosion, i.e. the deepening of the valley channel. So the features associated with this stage of the river, we have the V-shaped valley, this is a very deep, narrow valley at the youthful or the first stage of the river, usually created by pronounced vertical erosion. We have potholes. I already told that potholes come as a result of attrition, the hopping of material on the valley side, on the valley floor. These are small circular depressions on the riverbed. They are formed when pebbles carried by swirling water cut circular depressions within the river's bed. So potholes are very common in the useful stage. Number 3, we have interlocking spurs. Interlocking spurs, these ones are usually also known as an overlapping spur, is one of the many numbers of projecting ridges that extend alternately from the opposite sides of the wall of a young V-shaped valley. I know very well when you're illustrating the interlocking spur, we have this kind of nature. Sometimes they tend to appear like they are meanders, but the reason as to why you call them interlocking spurs is because for them they don't form on a flat terrain. Meanders form on flat terrain, interlocking spurs form in a rugged terrain, and that's why we're using the term projecting ridges that extend alternately from the opposite sides of the wall of a young V-shaped valley. So those are interlocking spurs. And then the other feature, of course, we have waterfalls and rapids. A waterfall is a place where water flows over a vertical drop in a course of the stream or a river. It's formed when there is a sudden change or drop in the bed of the river. That when the river is flowing, it has maintained uniform flow, but then it comes across an area where there is a drop, a bend in the course of the river. So water begins to fall off this cliff which has been created as a result of the interruption or the sudden drop in the course of the river. So waterfall is formed We know very well that we have a number of waterfalls: the Sipi Falls, the Oni Falls Dam, the Oni Falls, the Victoria Falls in Zimbabwe, Livingstone Falls in DRC, and others. On the other hand, rapids, these are sections of a river where the riverbed has a relatively steep gradient, a rough section of a river usually. So eventually when you go to a river valley and you observe an area where the water flow is very rough and produces some kind of whitish appearance, that section has got rapids. It usually causes an increase in the water velocity and therefore turbulence. That is where we have rapids, and we say rapids are characterized by the river becoming shallower with some rocks exposed above the flow surface. As the flowing water splashes over and around the rocks, air bubbles become mixed with it, and the portions of the surface acquire a white color, forming what we call white water. It is from this term that you hear people talking about white water rafting on River Nile. That white water rafting people are encountering rapids sections where rapids are very common. The other feature is a plunge pool, and we say plunge pools are large depressions formed at the base of a waterfall. Those of you who have ever been to Sipi Falls, people here from many campuses will have been to Sipi Falls before, where that water is dropping, usually by force of a hydraulic action, it scoops material before it begins to flow away. So it ends up creating a depression at the base of that waterfall, and that is what we refer to as a plunge pool. A gorge is a steep, narrow, and elongated valley, often formed when a waterfall retreats upstream, and therefore a gorge is usually formed. So when you come across a very narrow valley, very deep and narrow, and you say it's formed as a result of retreat. I remember one time visiting those ends of Bududa, and we came across a section of the river which appeared like that. It was almost looking even like a dry valley, but the waterfall had retreated. It was no longer there. It had moved, probably as a result of headward erosion. It had moved, or what we call retreat, moved upslope. So behind it left what we call a narrow, elongated valley known as a gorge. The other stage of the river is the mature stage, or the middle section, and of course this one is characterized by fairly low speed of water flow. Most of the work of the river here is transportation. The cross section of the valley is an open V shape, or sometimes U-shape, U-shaped valleys, and the slope of the river is gentle. The volume of the river increases and lateral erosion dominates. Features associated with the middle course of the river: we have bluffs. We know that bluffs are steep slopes of truncated spurs in the middle course, where interlocking spurs turn into bluffs. So in the middle course of the river, interlocking spurs turn into bluffs. In the upper course, we call them interlocking spurs. In the middle course, we call them bluffs. The second feature are waterfalls and rapids. These are also formed in the middle stage of the river and mainly caused by river rejuvenation. All of us know what river rejuvenation is. I may not go into that, but when the river renews its erosive power, it can again acquire a new level of gradient. You know well this one can be a result of uplift or downward, so eventually the river attains a new level and then waterfalls and rapids are formed. The oldest stage of the river is the third stage of the river, and this one of course is characterized by it is found at the river mouth. It is always the gradient falls, and therefore there is very slow flow of water. Here the main work of the river is deposition, and the cross section of the river is a broad valley or a U-shaped valley, and then the speed of the river is highly decreased, and the river valley is very wide. The features formed in this stage, one of them is the floodplain. Of course, we know that the floodplain is a gentle sloping plain of alluvium covering the valley floor down which the river flows in a meandering channel. The floodplain is normally formed when sediments deposited on the valley floor produce a gently sloping surface, what we call a floodplain, often marshy and contains numerous oxbow lakes. Most of the features of the old stage are found in the floodplain. Then we have of course, the floodplain, just like the name suggests, this is an area where we find a flood always. Whenever there is overbank flow, then that section of the river will be flooded because of the nature of the terrain. Then we have a braided channel, a braided river, a river that has split into several channels due to deposition of materials on the valley floor. So ladies who they know the term braid, probably they can help you define. Ask those ladies of yours in Kabale and in Bali and in Mukono, they will tell you what braids are. So it's the same scenario here, because when they are talking about braids, they are talking about these different ones. You know, when you talk about a weave is one thing, but braids are different, going to different directions. So a braided channel, the river here subdivides into several channels as a result of deposition within the river valley. Then we have a river meander. It's a bending section of a river. It forms when moving water in a river or stream erodes the outer banks and widens this valley, as well as the inner part of the river, which has less energy and deposits silt. So eventually the meander grows when there is erosion on the outer bank and a deposition on the inner bank, and eventually the meander begins to grow and grow. That curved section of the river is what we refer to as a meander. Sometimes when this meander is cut off, it leads to the formation of an oxbow lake. Of course, the other feature is an oxbow lake, which is formed as a result of a meander being cut off, and then it is left as a result of continuing that process. The erosion of the outer bank and deposition of the inner bank eventually lead to the cutting off of that meander, so that it's left behind as an isolated feature, which we refer to as an oxbow lake. Natural levees. A levee, of course, is an embankment on the river valley. As a result of repeated flooding, material is deposited on the river banks on either side. So you find that there's an embankment created on top of the normal surface that we know. So you find that there's material being created on each side, but that material is a result of deposition. These are the ones we refer to as levees. The other feature is a deferred junction. These are tributaries which lie parallel to the main river for longer distances, sometimes several kilometers, as a result of deposition. For example, these are two tributaries. This is a tributary, this is the main river, and this tributary is supposed to join the main river at this point. But because this point here has been heavily, the material has heavily been deposited here, so that now natural flow cannot happen. So this stream continues to flow parallel to the main river until it reaches a point where it can find a section. You've seen this with taxi men when they are what they call okuriakataka, when they are driving off the side and there's a section of the river which is quite big. There's a high between the kataka and the road. There's a difference in terms of height, so that the tires will struggle to join. So what this taxi man does is to drive through there until he finds a section where there's a relatively gentle section of the road, then it joins the main road. Those are what we call deferred junctions. The other feature are deltas, and we know that a delta is the low-lying swampy plain at the mouth of the river, which eventually becomes colonized by various plants. It's a result of prolonged deposition and collection of load at the river's mouth. The growth of the delta interferes with the flow of the river, causing the river to split into channels before entering the sea or the lake. These channels are called distributaries. What are the conditions necessary for the formation of a delta? One of them is that the river must have large load, because if the load is insufficient, then it will not reach the river mouth. It will not be sufficient to lead to the subdivision of the river valley as it enters the river mouth. There should not be extensive deposition in the middle stage. Yes, that's what the same thing we are talking about, so that all the material is deposited in the old stage. The river's load must be deposited faster than it's being removed. You know, for a feature to form as a result of deposition, it means that the rate of deposition must be higher than the rate of erosion. But if the rate of erosion is higher than the rate of deposition, then the feature will not form. The presence of a shallow joining sea or continental shelf is necessary for formation of a delta, and then the velocity of the river must be sufficiently low to allow most of its load to be deposited in the river's mouth. Deltas are of four types. We have arcuate deltas, we have bodies foot, and estuarine and cuspate delta. An arcuate delta is a type of delta composed of mainly sediments such as gravel and sand, and it has a shape of an inverted cone. We all of us know the shape of an inverted cone. The shape of an inverted cone. That is how it approaches. That's how it subdivides itself as it enters the lake. Examples of arcuate deltas: we have the Nile Delta, the Niger Delta, the Ganges, the Indus, the Mekong, and the Huanghe deltas. The Badi's foot delta, on the other hand, that's like we're talking about the Badi's foot. We know the Badi's foot. Those of you who eat the feet of the bird, I know very well my people in eastern Uganda will eat the feet of the bird. I don't know about Westerners, but the people in eastern Uganda and northern Uganda will eat. It's the Baganda who don't want to eat the feet of the bird. But this is a delta which has a shape like that of a bird's foot. It's formed of fine sediments such as silt and characterized by few distributaries, sometimes 3 or 4, bordered by levees and cut out from the shore. This type of delta forms when the power of the waves or currents is low. We have, for example, the Mississippi Delta in the USA and the one on the Omo River in Ethiopia. Estuarine deltas come, of course, an estuarine delta derives its name from the word estuary, and an estuary, we know this is a drowned river mouth. So this is formed by materials deposited in the submerged mouth of a river. And it takes, an estuary appears like an extension of the sea into the river, where that section, when you come across a river with that kind of river mouth, that is an estuarine delta. An estuarine delta does not have vegetation like we have the case of the Badi's foot or the arcuate, but this one appears like a drowned river mouth, so that it so appears that the lake is extending into the river. The cuspate delta is a delta which looks like a tooth-shaped feature. It is formed when a river drops sediment onto a flat, straight shoreline with stronger waves, making a pointed tooth-like shape with sides curved by regular opposing and gentle water movement. It extends to the sea as a V shape with long curving sides. Examples of such deltas are the Ebo Delta and the Tebel Delta in Italy. Thank you so much. God bless you.